All right, welcome back to Airflow Lab walkthrough. Uh, this is the second part of it. I had to stop recording because the first part was too long. So for the second part, we should finish our pipeline. What we've done so far, besides getting set up and playing around with the UI and very simple DAGs, is that we extracted the data from Austin Animal Shelter website and saved it to a local file. Then we transformed it, which means we cleaned it and we made it consistent with the Snowflake data star data model, dimensional data model star schema. After which we saved the result to a bunch of Parquet files in local storage. For the next step, we want to actually load this data into the database. But before we do that, I wanted to note something, the difference between what we're doing right now with what we've done before, but as having a scheduler on top. The key difference right now is that when we are doing the transform step over here, it's Airflow that's doing the transform. It's happening within Airflow. And notice also that my transform step is not in any kind of Docker container. It is in Airflow, and Airflow itself is running in container, right? But the job is running on the worker, not isolated from anything else. This is bad practice. I'm doing this because I don't want to have 3 more hour-long videos, right? But this is one of the most common anti-patterns. And it's an anti-pattern, but it is very common. People do that all the time, even though they shouldn't. Is that they run their Python code within Airflow. Airflow is not a compute engine. Airflow is a scheduler. You can imagine if you start doing a lot of these little pieces of code that you run in your Airflow, right? It's a fancy cron. It's not going to go over very well, right? So before we had our transform script in a Docker container. It was nicely packaged with all the environment variables and packages that it needed. We unpacked it here and just threw it in the DAG. Ideally, you would still have it packaged in a Docker container, and instead of calling Python operator, you would call something like Docker operator. And Airflow itself would just spin up the container, but the execution will be happening outside Airflow. And that's kind of the way it's done a lot of the time, that any kind of little task that you had is in its own container that are all orchestrated with, say, Kubernetes. Another alternative to executing code on Airflow is, for example, make a Spark job. So instead of having this transform run as a Python script inside Airflow, Airflow just initiates a Spark job, and Spark itself actually does the transformation, right? Because Spark is a framework, right? Spark is a whole piece of software. It's not just like PySpark, right? We interface with Spark using PySpark, but it's a whole standalone thing. We can have a Spark cluster and have it run jobs, and that's another way to handle this. And you can combine those, right? So putting Python code into your DAG is the first step. It is usually the least you can do, and something that you should get rid of as soon as you start your application or your pipeline starts getting larger. But for us, this is what we're going to do. That said, we still want to connect Postgres database. And I mentioned before that Airflow does come with Postgres service, but it's not the service that you should be using for your backend database. It's fine for, you can do it for like a tiny project, maybe it will be fine for this, but it's pretty bad practice because it is the database that stores metadata. And it doesn't even, I've said it before, doesn't even expose any ports. So it's not intended to be used outside of this Airflow internals. So we are going to do what we've done before, is that we are going to add another container that has Postgres in it, right? Because, well, Python code we kind of can run on an Airflow. If we want to have a Postgres database, we can't have it like in Airflow. That's what does that even mean? So we are going to add a another container to this Docker Compose at the very end that will have our backend, in this case, I guess it's a data warehouse Postgres database. So here I have the Docker Compose from before, and here was my setup of my database. I'm just going to copy it into the Docker Compose for Airflow. I'm just going to remove those there. So notice that there are slight differences with Airflow's Postgres. They pull Postgres 13. I pull Postgres 16 because that was the latest when I did this. I have Postgres user password specified to these, and I have a volume DB data, which I will also need to add the volumes. And we have an init script, right? Remember, we have an init script that creates tables. I'm going to keep it here, but like the better way to do it would be to have another task in Airflow that just runs the init script instead of having it in like hidden inside the container. This is actually a pretty bad place for creating tables. Oh, and I probably should actually add this init script to my project. I'm just copying it from the setup for this lab. There we go. So this image, volumes, ports. I will also add the health check so that I wouldn't have this problem of my thing trying to access the database that's not ready yet. So I'll just copy the health check part from the Airflow health check. But I will need to do some changes because they could just hardcode the user Airflow. I want to use my environment variable. By the way, notice that I have this Postgres password user DB in this service, in the DB service, and then there are Postgres user and password environment variables in the Postgres service, but they don't know about each other, right? Because each of those services is running in a separate container, so there is actually no interaction between them. But I want to, in the health check, instead of having user Airflow, I want to have user defined by environment variable, and I want to have the database defined by environment variable, in which case I actually need to change this health check a little bit. I need to use CMD shell instead of CMD because that's what will allow me to use environment variables. And then I'll just write the full command that I want, which is pg is ready, something that checks whether Postgres is ready. My user will be, I think I have to put $2 to call an environment variable from here. Postgres user, and my database will be Postgres database. All right, so supposedly this will, every 10 seconds, it will send a little ping. PG is ready, coming from this user and this database to check whether the database is ready. All right, so I will save this. So far, I just added stuff to Docker Compose. I didn't change my DAG, and I have this stuff still running from the previous video, so I'm gonna have to stop it. And then I'm going to do, once it stops, taking a while. There we go. I'm going to do Docker Compose down and volumes. Just clean out everything that I've created so far. And then I'm going to start it up again. And you see that it's running, it's pulling DB, right? It's pulling DB service because previously it was not there. All right. Let's wish this was quicker. Okay, well, I'm gonna pause and get back to you once it's done. Whew, that took a while. See, you get to skip this, but I have to sit and watch and while it works for like 5 minutes. All right, so it didn't give me any errors, which is a good sign. So I'm going to go now to, let me close this actually. Let me just open a new terminal and run Docker PS, which again shows just all the running containers. And I should see there we go, DB1, right? So DB was the name of my database service. And there it is, it's running and it says healthy. That's what the health check is for. So I can, again, enter this container. So Docker exec IT for interactive mode, name of the container, and bash. This will get me into the bash shell of the container interactive mode. Hopefully I have a database there so I can run PSQL. Remember our SQL lecture from a while ago? PSQL requires a user, and the user was Alex, and a database. The database is shelter. And there it is. It exists. Fantastic. I can run select one. So database is there. I don't have any DAGs running. I still have my DAG that I programmed before, but it doesn't so far interact with the Postgres database, but the container for it, for the Postgres database already exists. So the only thing remains is to just load the data into it. Back in the previous lab, I had this function called load data, which was creating a connection to a database defined by URL environment variable URL, and then I was loading all the tables in a loop. So let me copy this and go back to my new lab, and I'm gonna go to my ETL scripts folder and create a file load.py and put this in there. I think I will need some imports. I will need pandas and SQL Alchemy probably. Let's take these. I don't know parse. All right, so First of all, it used to take a data dictionary. The way I wrote it was that I had like the name of the table and the actual reference to the data frame containing the data for that table so that I could do more convenient loading. You probably, most likely you did it differently, and that's okay. But now that all my data is no longer in a data frame that's in memory, but it's hanging out in Parquet files in my local storage, here I will need to have a link to the file that I'm going to be loading. So I'm going to once again do source. See, well, maybe I'll do table file. Table file. I'll also need to know table name because that's what ToSQL requires. It requires me to specify the name of the table. All right. So previously we had this environment variable db URL, and it was defined in the Docker Compose file for the service that run my script. I don't have a service that runs my script now. I just have Airflow. My script is no longer containerized right now. So where would I shove that URL? Because I no longer have a service in Docker Compose where I can put this. Well, like I said, the best practice is actually having a service to put this. But for this lab, remember I showed you that there is X Airflow common. So a bunch of common environment variables. And I'm going to add this right here. I'm going to say maybe like custom environment variables db URL, and it's going to be, I'm just going to copy it from the previous lab. It's going to be this. And it's the same, I'm keeping the same password and data and user and port, but like ideally these would also be filled sort of dynamically, in the sense that instead of having this, like I would reference a variable for Postgres user, I would reference a variable for Postgres password, I would reference a variable for Postgres variable, but like I said, this is going to make the already long demo even longer. So just shove that URL over there. So now it will be accessible to this part, and hopefully we will be able to establish a connection. I need to change the way I do this, because now I need to first of all read Parquet table file, and then I will send it to SQL. All right, now time for some serious data engineering. Think about what we're doing. Our source data has this CSV that's updated every day. We're pulling it every day, the entire CSV. We're creating tables from it. When we are running our load, we have some choices. We already have data in the data warehouse, right, from the previous days. We can either overwrite everything. So we can remove everything that's in the data warehouse and just write everything anew. You know what? This is done. It's done sometimes. It's not that outrageous. Your data pipeline usually runs in the middle of the night. You have a lot of time to remove and load all the data. And with some storage options like we discussed, this might be the only way to do it because you can't update data in place. But it is kind of resource intensive, right? The problem, besides general problem that it's resource intensive, the problem that we're facing here right now is how to do that. If I wanted to do this, if I wanted to replace all the data in a warehouse with new data, how would I do this here? And if I want to stick to just using 2SQL, which I don't have to, but for brevity we will, I could change if exists to replace. That would drop the table where it's inserting and then replace the data with new. Here's the problem. If you try to do that, I don't want to demonstrate it because my DAG currently downloads a lot of data. Actually, maybe I can run it in a container. Let's see. I also need to rebuild because DB URL is not specified. Okay, so just believe me. If you do this, right, and let's say you're loading a dimension table, like you're loading the table for information about animals. SQL will complain because it cannot drop the dimension table. Because the way our dimensional data model works, right, there are foreign keys between dimension and fact table. If I go to init SQL, there they are. So there are references from the fact table to dimension table. I cannot delete the dimension table because then the references in the fact table will no longer be valid. So, and that's the error that you will get if you try to put replace into here. One way to do it is to just remove the foreign keys. Well, there are schools of thought on this. For example, in BigQuery you don't even have foreign keys, right? So that's not a problem if you are loading into a BigQuery as your data warehouse. This is not even going to be a problem. But generally, like if the data warehouse supports foreign keys, we want to have them for data integrity and for our own integrity. So this is the problem, because what we would need to do, we would need to remove the tables in a special order. We would need to remove them first, the fact table, then the dimension tables. But the problem is that when we load them, we have to load them in the opposite order, right? So we cannot have deleting the table and loading the data in the same function like I'm trying to do here. So one way to do it would be to have another task that drops all the tables and then have another task that loads the new data. We are going to take a slightly different approach in that we are going to check what data already exists in the warehouse and then add new. Now, here's the problem, right? When you have a new outcome for an animal, it's a new outcome. Like the fact of an outcome does not exist in the table yet. But the information about the animal already might. Or it might not. It might be a new animal. Because we only have this one CSV that has all the data together, right? We don't actually know whether a particular outcome is for an animal that didn't previously exist, or it's for an entirely new animal. So we need to have a way to add the information about a new animal, potentially, or a new other dimension, new date, into the data warehouse without like deleting everything and adding everything back. So ToSQL actually allows you to do this. There are probably better ways to do it with SQL Alchemy, but we're learning ToSQL, so that's what we're going to stick with. So Pandas ToSQL has this parameter called method. So method is controlling the SQL insertion method that is used, and we can have a custom function that uses this. This is where using SQL, plain SQL, would be easier, because plain SQL has stuff like merge or upsert that you can just call, and you don't have to like fiddle with the parameter of a function and write your own insert method. But fortunately, that's a common enough problem that Pandas actually provides you with explicit ways to do this. So there we go. Use method to define a callable insertion method to do nothing if there is a primary key conflict on a table in the Postgres database. So if there is already a record with this key that exists, do nothing. Maybe a better way would be to actually update, but we're going to do nothing. So I'm going to copy this code. Let's see. Move these things. Okay, do you want to hear something funny? So all these have like a little copy button, but if you press copy, it will copy it with all this stupid stuff, I think, or at least that's what it used to be like. Yep. See, if I press the copy button and then paste, it copies it with this, and I have to delete manually. But if you don't use the convenient copy button and just try to select, then it selects the correct part. Which is like, okay. Knowing how these are actually programmed behind the scenes, because I've worked on documentation, it's like, really? This should be very easy to fix. But anyway, back to our thing. So this is what we copied, right? There is an importing insert function. Then there is a function insert on conflict nothing. The signature is a required signature when using a custom insert method. And then it does something. And yeah, it does like on conflict do nothing. I'm not even going to care about this. Copied it from Pandas documentation, must be good. I'm going to just move my import to the beginning of the file. But that's it. What do I need to do? I need to add this thing to my file. Oh, and I need to put append back, because replace will try to drop the table and complain, whereas append will try to use this insert method. All right. Okay. So I have this function inside my load data. Oh, this is another thing. A is the primary key in the conflict table. I want to use this function load data to load all my tables. So I'm going to make this a parameter. It can be animal ID, it can be date ID, it can be outcome ID. I'm just going to make it a parameter and replace it also in index elements. So key. All right. So I changed my load data function to use this new insertion method, which I copied from pandas docs, which inserts the record if it doesn't exist and does nothing if it already exists. And this is to circumvent the problem that we cannot drop the tables in the same order that we want to load them. And then we would have to like write 2 more tasks, and we don't want to do that. So I'm going to save this, and I'm going to go to outcomes DAG and import this as well. And add a new task. Load. Actually, maybe I'm gonna try to just load one dimension. So maybe I'm gonna say load animals dimension. I don't want to try to load everything if it doesn't work. What were the parameters? Table file, table name, and key. Table file, let's go to transform and see how we made it. Target directory plus dimension animals for cat. But target directory is called this. Then we have table name. And table name is, I'm going to look up in its SQL, is dim animals. That's the name in the SQL file. And then the key, so the thing that we use to check for duplicates is going to be animal. And add it to our pipeline. Load animals dim. All right. Let's go to the UI. I think I need to close a bunch of those things. Right, I restarted. Oh, I need to restart. Sorry, folks. I forgot that I need to restart everything. The reason I need to restart everything is because we added this DB URL into Docker Compose. So now everything has to go down. If I had a bit more time, I would edit this and like speed up these transitions, but that's not gonna happen. Fortunately, this should be quick because most of this has been built before. Let's hit pause. All right, it started up. I'm going to refresh this and log in. Run the DAG. Let's see what it looks like. Oh no, it's going to start running for every day now. That is a mistake, right? Because I put down everything and then I restarted my Airflow, and my DAG starts on November 1st and runs daily, so Airflow needs to backfill it, and so that it will have to download the entire file. 6 times. The way to avoid doing that is to use their API, where you can specify the date range. And that would be how you do it in more realistic situation, where your pipeline actually, your DAG is parameterized by date, right? And it sends the requests, the API request, to retrieve only information for a particular date. And I'm not gonna do that because that's another half an hour. But that's how you would do it. All right, I'm gonna wait until at least one of those complete, and then we'll move on. All right, this took a while, and we've seen something interesting here. Lots of reds. One of the tasks did not even start. Also, it takes like forever to get a log. And this one did give me a log, but it's very short. And the most I can say is task exited with return code -9. And if I Google this, now I can't even Google this, so you probably can figure out what's going on. Possibly your logging is badly configured or you have not enough resources. I've been running so many containers today that I'm guessing I have some memory issues. So what I'm going to do is I'm going to restart everything completely for my own. Hopefully you will not have this problem because you are not running this for the third time a single day. And then we'll get back to loading data.